Hello, it's time to play some dominoes. Let's play pips. See how this goes today. Start with the easy puzzle, of course. All right, I don't like how much they're elongating these pages for some reason. Anyway, we got a 0, which must go in here, and we've got 2's to fill the equivalence region clearly, greater than 2 here, and a 1 here, and that's that. Okay, there we go. We'll move on to medium. Okay. We've got a 4-sized equivalence region, and we've got a 2 here. So the 2 looks like it cannot be achieved in a single domino, but it could be 2 1s or a 2 and a 0. What about the 4-sized equivalence region? What will comprise that? It could be 0s. It could be 3's. I think that's it. Well, greater than 5 is a 6. And we can't make the equivalence region out of 2's, so that'll go here. So that's fine. The 10 will then need to be 2 5's because we've already used our 6. It can't be 6 4, and in fact we have no 4's anyway. So how many 5's do we have? We have 3 5's. So we have, let's see. If we made the 2 up of 2 1's, so if we made the 2 up of 0's, then we couldn't make the equivalence region 0. So if we made the 2 up of 2 0's, the equivalence region would need to be 3's. Does that cause any problems for any reason? We have exactly 4 3's. So if that were true, one of the 3's would have to go into the 10 to allow the 10 to have a 5. No, that's not necessarily true, actually. Well, no, I think it is. Actually, I think it is true. But it's either that or it would have to go out into nothing just to get rid of it. I don't know. What about the other? Oh, the other equivalence has to be a double. Oh, sorry. That should have been the very first thing I looked at. So that's the blanks. Okay, that's fine. So now we know that the 0's cannot be the equivalence. So the equivalence is in fact 3's. Okay, that's fine. So in that case, we do need the 5 3 here. That is now necessary. And then that means, what else does that mean? We can't put the 3 1 going into the 7 because then we'd need a 6, which we don't have. So it also can't go here. And nothing, I don't think anything can go. No, we could put something there. Maybe this does go there then. Could go here as well. What can go down into the 7? Can't be the 0, can't be the 1, so it's the 2. Yeah, again, this is the thing I actually should have been looking at. So 3 2 goes down there. Then we need a 5. We have a 5 1 and a 5 0. We can no longer make the 2 out of 2 0. So the 2 is made up of 2 1's. So that one goes here. Then we have another 1 3 pointing into there. Then we finish our 10 with our other 5. And the 3 goes here. And that's that. That's the medium puzzle. I probably should have been able to do that one a little more quickly, but there we have it. All right, we'll move on to the hard. Okay, another very compact grid, just like we had yesterday. So we've got 4-sized non-equivalence regions. Those aren't usually very helpful to start. We have a 1. How many possibilities? We only have a single 1. And it can't go this way. So it goes into the inequivalence region, but we don't know if it goes down or across. I think it might be a case where it ends up not mattering. But it might. It depends, I guess, on some other, how the 0 and 2's are pointing around. I'll put it in there for now just to remind myself. So we need a 4, which cannot be the 4 5, because the 5 is going into the inequivalence region one way or another. So it's not that. Could be a 4 2 or a 4 4 or a 4 0 or a 4 6. Okay, so that is not very constrained. We've got a 2 and a 0. Oh, we've got 2 2's, and those are both spoken for. So those have a 4 and a 6 pointing elsewhere. Now, neither of those can be pointing across. So both of our 2's are pointing up and down into inequivalence regions. They could be the same. No, they could be the same one. If they're both pointing down, they could point into the same inequivalence region. Is there any reason that doesn't work? We then need a 0 pointing up. I don't see any reason that doesn't work. Okay, so that I can't immediately roll that. Actually, if it did that, we'd need a 3 and 5 connected to each other. That works as well. Maybe this is, in fact, how it works. Let's just see if we can disprove it. We then need a 3, 5 pointing up. That works fine. We still don't know which way this goes. I'm just reminding myself that that's true. Let's see. Oh, I forgot about the 3-sized equivalence region. Sorry. That could be 4s. In fact, with what we have left, it needs to be. So we'd need a double, we'd need a double 4 here. And then couldn't put a 4, 5 in here because that would break the inequivalence region. Actually, with that being the case, sorry, this does need to go this way, because if it went this way, we'd have broken things. That's based on the 2's pointing down. But that is what I'm trying to prove out now, so that stays true. So we can't have a 4, 5 pointing in there. We could have a 4, 0 or a 4, 6. And then we have another 4 pointing down there, which is also a 4, 0 and 4, 6. That means the 4, 5 has to go somewhere else, which means down here. And in order to not break the equivalence region, we have to put it in that orientation. So I guess we can put the 4. I guess the 4s can go in either order here. It doesn't actually matter. It adds up to the same thing. And then that allows us to finish the 0, 6. And that's broken. So sorry, this whole thing, I think, is now broken for that reason. So we went through all of that just to prove that I think what we've proven is that the 2's can't be both pointing down, which is what I wanted to disprove. So I did. It just took longer than I thought maybe it would. I think that's what we've proven. Apologies if I've just declared something false. Okay. So I think what that means is, well, I was going to say at least one of them needs to be pointing up, but it's actually only one can be pointing up from the 2's. I don't really know if that tells me anything. I mean, it tells me that we can't have a 2, 5 pointing up, but we don't have one of those anyway. It's still true that we need, regardless of the way that this is oriented, it's still true that we need a double in the equivalence region, which I guess is 4. That's just true no matter what. So this 4 does need to be going elsewhere. It could be 4, 5 pointing down. Right. Okay. Lots of 4s. If it is 4, 5 pointing down, that would be the most specific thing we could do. Then we need a 3 just in terms of constraining things. Otherwise, if it points in here, it couldn't be the 5, but it could be anything else currently. I don't know if that helps me necessarily. What about these non-equivalence regions? How many things do we have spoken for? We have all of our 4s spoken for in total, I think, because we have 3 here plus 1 more is 4 there. 1, 2, 3, 4. No, we don't. We have a lot of 4s. We have 6 4s. Okay, never mind. We do have our 2's spoken for, so no 2's in the inequivalence regions. That doesn't really matter. We have a single 3, so that can't be in the inequivalence region. So what do we... I don't really think this is very helpful, what I'm saying right now. There probably is a way for it to be helpful, but I'm not immediately certain of what it is. What about if the 3 doesn't connect to the 5? Is that helpful at all? We then need either a 5, 4 or a 5, 2. We don't have a 5, 2. So if this were the case, it would need to be the 5, 4. Is that useful? We don't have a 2, 0, so the 2 would need to point up, which could be a 2, 6 or a 2, 5. Oh, no, it couldn't be. No, sorry, 2, 6 or 2, 4. Sorry, just misspoke there. Similarly, this 2, 0. Oh, so actually, well, okay, this 2, I was going to say it couldn't point up, but that's not true because this could be this way, and then that 2 could point up. So I don't even know if that's useful. Maybe I should get rid of that for now, so I don't confuse myself. We need something pointing up from the bottom of the grid. That doesn't seem very useful either. Although it is useful because it means this 2 needs to be pointing down. Yeah, okay, that was always true. That was always something I should have observed. And didn't. That one's always pointing down, which means, yeah, this one's pointing up, but at this point, I guess that does seem clear. Although that also means the 1, 5 is pointing this way. So I guess that's true in this world, and possibly all worlds. So this is pointing down. Let's just put something in there just so I can think about it. I think that actually 2, 6 might actually be good there, now that I'm thinking about it. Zero, 2. So the 0 would need to be pointing up with a 4 or a 6. We do have a lot of 6s, actually. So I think because we have 3 6s, one of them needs to go in this empty thing just to get rid of it. Otherwise, we'll have more than we need in the inequivalence regions. That's good to know as well. So maybe that goes there. Then we use the other one with connected to the 0. Yeah, that actually works. Yeah, okay. I keep getting into this thing where I sort of start seeing the important stuff after I've already put a bunch of stuff in the grid, whereas ideally I would see it earlier and use that to help me narrow things down. Yeah, this, oops, let's see, let's put that back. Yeah, that's interesting. This was constrained in various ways, but I only kind of was scratching at them over time. Anyway, there we go. Those were the pips. Got there in the end. Back tomorrow. Bye for now.